Okay, so we are ready to start. Welcome to the webinar today with TI and Edge Impulse. I'll pass you over to the team shortly, but I just wanted to mention that we've got the Q&A function that we're using today. So if you have any questions either for Edge Impulse or TI, please share them in there, and then we'll either answer them live where we can, or we'll get to the Q&A at the end and we'll ask them there. So from that, over to you, Josh.
Hi, my name is Joshua Buck. I'm a solutions engineer here at Edge Impulse. We are presenting today our integration with the TDA4VM, a processor from Texas Instruments that's used for machine learning and AI applications. With me today, I have Manisha from Texas Instruments. She's a product marketing manager, and she'll be presenting today about the TDA4VM's capabilities from Texas Instruments' point of view. And then later in the slide deck, we'll go through what is Edge Impulse and how to use that device with Edge Impulse. Manisha, if you can go to the agenda, we'll just rehash that one more time. And then we'll also be able to have a Q&A afterwards. So if you have any questions, please type them out in the chat and we'll address them as we get to near the end of the presentation. Manisha?
All right, thanks, Joshua. So good morning, everyone. My name is Manisha Agrawal, and I'm Product Marketing Manager with Texas Instruments. Very pleased to talking to you all today and introducing our family of processor. The first in the family is TDA4VM, and would like to talk about its capabilities and how it can help you revolutionize the product that you're developing, in which you are intending to add the AI functions, or you have already have it, but you would like to improve it, right? So there is no secret that embedded vision AI is revolutionizing factories to home, right? Applications from factories to home, starting from single camera to multiple cameras, or just directly, having the streaming videos ingested to make the legacy camera intelligent without having to change your cameras, or having the cameras along with interaction via the HMI means, or maybe just not having the cameras in a box or the stationary fashion, but having it integrated with multiple other sensors such as LiDAR or radar in mobile machineries or robots for last mile delivery and warehouse, right? So we'll look at the spectrum of the products from machine vision, making the smart factories, or the smart retails, or the building automation side. So there's a holistic gamut of the products that you can build, or you can make your existing products, which are non-camera based as well, intelligent based on the vision sensors, right? So vision AI is really making our world smarter and safer. But what we know is that there are two aspects of the AI development. One is the AI model training, and other is AI inferencing. At Texas Instruments, we are dedicated to provide an embedded processor, which are not only cost optimized, but also power optimized, as well as giving you the right performance needed for your different AI application need. And we know how to make our processors best program and simple to use, right? So our focus and capabilities and strength are on the AI inferencing side. But there is an expertise needed all over for the AI model training, where machine learning expertise, data scientist expertise is needed for you to either design your model, train your model, optimize your model, right? So, but there's this entire journey from the model training to inferencing. It can be a time-taking task for the industry, companies, people, those who do not have the right expertise. And that's where, with our collaboration with Edge Impulse, we bring the simplified journey for you from model training to model inferencing, all under 15 minutes with our no-code to low-code tools. So if you are new to AI, or you are already an expert to AI, the Edge Impulse tools give you all the flexibility to start your AI journey. And similarly, when it comes to the model development and deployment and inference running onto the TI processor with our integration to their service, they provide you that flexibility to just compile the code for TI processor as well deploy over the air just with few simple clicks. That Joshua will show you in the future slides. When it comes to the AI inferencing, our tools, our simplified tools with the hardware agnostic programming, that really gives you the flexibility to just get the best utilization of our high performance processor without indulging into the low-level software details. And again, we will look into those in my future slides. So looking into the TDA4VM, TDA4VM is our first processor in the family of the processor catering towards a vision-based AI. It is a processor with 8 TOPS of hardware accelerated AI, quite powerful, giving you 2x more frames per second per TOPS compared to the leading GPU-based solution. And it just doesn't have the AI accelerator onto it. It is based on dual-core Cortex-A72 CPU and comes with integrated series of vision accelerator, starting from the image signal processing integrated into it, to the stereo depth acceleration or lens distortion correction and dense optical flow, right? So there's a series of hardware accelerators with high-speed interfaces from multiple Ethernet port up to 8, or the 4-port of the PCIe and multiple USB ports. Along with it, it also comes with the pin-compatible solution for industrial and auto-qualified SoCs with optional functional safety solution should you design your product catering to those markets. Our processor with high performance frames per second per TOPS gives you the ability to do the MobileNet device, MobileNet model kind of architecture, 700 plus frames per second. When it comes to object detection, you can get roughly 400 frames per second. So it's really, really powerful processor, enabling you to just not only process, say, one single camera, but multiple cameras you can connect to the device and then do the AI processing on them simultaneously. So as I mentioned, that it is just not about our differentiation to the SoC architecture, but we really make the development and deployment and the production on our processor very, very simple for our customers. So to evaluate and develop on our processors, you do not need to really buy any hardware kit. You can use our free online cloud service tool and access one of our hardware remotely just with the simple access through your Chrome or any other web browser. Log into ti.com/edgeAICloud, access our cloud tool, bring your AI model, or use the model from our large collection of Model Zoo to deploy on our processor, compile it, and either collect the benchmark inferencing or develop, collaborate with your team members, those who are remotely located into different locations, right? So it comes with simple scripts, which I will talk about in my next slide, that how under 5 minutes, we enable you to use our processor, bring your own AI model, or use a model from TI Model Zoo and get started with your AI project. Along with the free online cloud tool, we also provide you very low cost, small form factor hardware development kit, which call as SK-TDA4VM Starter Kit, which enables you to build any of your camera, AI box, robots, or any other vision AI applications. Comes with simple projects for you to get started with, again, under 5 minutes. And for you to learn anything about TI's AI offering, go to ti.com/edgeAI and you have access to all the resources to get you started. We also have our own series of webinar on the AI topic, which you can just check offline at your free time, logging into the link that I'm sharing in my screen right now. So just enhancing on to the topic where I mentioned that it is really easy to program our high performance SoC. We really have made it hardware agnostic accelerated programming through the TI tools and middleware, which are production qualified, but then we wrap it over the open standard, industry standard frameworks and APIs, such as TensorFlow Lite, Onyx Runtime, and TVM. And I'll talk about that, how that you can use your favorite APIs based on which training framework that you're using for development and program our SoC with just few lines of Python APIs, which you're already familiar with. So not only with the easy to use software stack, we also provide you extensive tools for faster AI development. And that starts the journey from, the decision making, where which model is the right model for you, right? Should you bring your own AI model? Or if you do not have that starting point, how do you get started with the rich collection of the model from TI Model Zoo, which are pre-validated, pre-optimized to take best advantage of TI AI hardware accelerator. And not only that, we provide you series of tools to help you train your AI model for our hardware by making it quantization aware training to reduce your loss with the floating point to the fixed point when you run on our processor. And we also provide you tools, as I mentioned before, the free online cloud service tool for your benchmarking or development onto our cloud service without even having need to buy our hardware. And once you kind of have gone through that journey, you can then deploy onto our hardware with the simple GStreamer APIs with command line, pipeline, and plugins, and build end-to-end applications from the camera capture to the decision making that you're taking, and then the action on that decision that you're taking. So as I mentioned, that we have large collection of models in our model zoo, starting from classification to object detection to semantic segmentation, or you can bring other sensors such as the LiDAR sensor for 3D point cloud generation or object detection with that, human pose estimation, face detection, and several more tasks that you can find in our rich collection of model zoo. And they're all based on the latest and the greatest AI models from the community, such as MobileNet or EfficientNet, EfficientNet, ResNet, RegNetX, YOLOX, YOLO V4, V5, DeepLab V3, point pillars, transformers, and more. And we'll talk about how we are enabling several of these models from our model zoo into Edge Impulse service to give you that starting point of doing a transfer learning on pre-optimized models to solve any of your AI tasks that you have. We have growing community of developers on our software and our processor with our GitHub repository, with having several folks from the community contributing to it. And we encourage you all, if you have a need, to look at our GitHub repository, use it, and contribute to it. So just I would like to expand a little bit, give a little more clear picture on how the entire programming journey looks onto the TDA4VM processor. So this is a processor for vision-based AI application primarily, whether you're bringing single camera to multiple cameras or other sensor modalities. Now, if you have two choices for your AI framework, AI training framework, if it is TensorFlow, we encourage you to use either TensorFlow Lite or TVM or Onyx Runtime, one of those inference engine you can use. Bring your floating point model and compile it onto the Linux machine with the TF Lite APIs itself, or the Onyx or the TVM, whichever API that you're using. You get the compiled artifacts, which are in the fixed point fashion, and then deploy it onto our processor. But if you're using PyTorch, then you have the option either to use TVM or Onyx Runtime, and then go through the same journey utilizing their APIs, whether it's in the Python fashion or the C, C++ fashion, and deploy it onto our processor. Underhood, our own software takes care to offload it to take advantage of our hardware accelerator. And we provide it in a fashion where if our hardware accelerator with the optimized library doesn't support that operator, the software framework takes care automatically to offload it to the ARM CPU. So you are not stuck in your journey of getting your AI model and utilizing the best fashion way the full capabilities of our SoC. So really, really simple to program using your favorite Python or C++ APIs with TensorFlow Lite, TVM, or Onyx Runtime. Develop and prototype on the Linux machine. Use the same APIs to offload it and make your embedded product develop within few minutes. So with that, I would like to hand it over to Joshua to talk about Edge Impulse and then how TDA4VM integration into Edge Impulse enables your development from non-intelligent product to intelligent product under 15 minutes. Over to you, Joshua.
Great. Thanks, Manisha. If I can take control of the screen or share my slides, and then I'll be able to do my presentation. All right. Let's go. Is the screen coming through? Yes. Excellent. All right. Yeah. So what is Edge Impulse? Impulse is a platform. It's a website, a series of SDKs, and a way for you guys to more easily develop models and get them on devices like the TDA4VM. We are an integrated ML platform. It is a royalty-free business model, so therefore there's no impact to your bottom line on your BOM cost. That is, if you're doing deployments from Edge Impulse, you don't have to pay a license. And your IP stays your IP. So what you develop on Edge Impulse is yours to keep. And there should be no black boxes. And if you ever encounter one, let us know. But the source code is out there for the models and for the SDK that you would run on your embedded devices. We're going to walk through Edge Impulse today, but this is a high-level overview of what your experience would be like with Edge Impulse. You have your Edge device, like the TDA4VM, and you can connect it to Edge Impulse to collect data so that you can build a ML data set. You can design your model, so you either can bring in TI's models or build one from the ground up using the Keras API, or visual mode that we support. You can test the model in the cloud before you even have to deploy back to that device. And then finally, which is all why we're here, is to how to get that model back onto the device and do inferencing against it. And we make that simple as can be. We'll walk you through a few of the versions of a few of the slides of the website, and then we'll actually do a live demo here in a few minutes. The collection story is basically that you can take data on the device. We have developed firmware that runs on the device that connects to our cloud service. And you can acquire images, acquire audio waveforms, temperature samples, things like that, depending on the supported dev kit. In this case, we'll be doing an image acquisition. But mainly what we have here for data collection is a way to organize your data sets, label it, and I'll show off some of the auto labeling, and make sure that you're able to collect the data set that you need and understand what that data set has so that you can properly train models. And when you're designing those models, we have what's called an impulse, which is basically a series of steps or boxes that you have to set up in order to either take that image data, or let's say it's time series data, perform some sort of DSP analysis on it, and then feed it into that model. And then we tune those blocks, or you can design those blocks so that it fits your particular application. These blocks that we present in the graphical interface have code behind them. That code is also on GitHub so that you can understand what that code is doing to your raw data. And it makes sure that you can share that knowledge throughout your ML teams. So there's no ambiguity about what you're trying to design for, how your data gets into the system, and then how it comes out. Before you deploy back to the device and actually start testing with it, you should test in the cloud, right? So we also have hardware aware development. That is to say that that same device that you collected the data, you can send that data back for testing the model so that you can refine and make improvements to the model as well, right? And then there's a ways in Edge Impulse to also tune your application for the particular target in mind. And then lastly, we're going to show off how we can deploy to a target. Here's a screenshot of the deployment page where it has the Texas Instruments TIDL library. And then down below that, you can have a no-code option of getting a pre-built binary that runs on the system. We have a number of other silicon targets out there and a compiler that works for many of them. And again, the source code is open on GitHub, from which you can go download and then develop against as well. So I'm going to go through a live demo of developing with the TDA4VM, and I'll hop into the website and actually show you it live and in action. So I'm going to skip over how to create an Edge Impulse account. You just go to edgeimpulse.com and create an account, but you'll be landed on a page like this, which is a dashboard of some of your projects. And I will go over to projects and create a new project here. I'll call this project, TDA4VM. And the project has been created. From here, you'll be presented with a wizard from which it will describe, what kind of task you're trying to select. In this case, we're going to be collecting images, and we are going to be doing object detection. All right. And from here, you can either connect to a development board, which we will do with the TDA4VM, or you can upload existing data. So there's a way to take previously acquired data, or potentially a data set and get it into Edge Impulse as well. So let's go ahead and connect a fully development board. This will bring you over to the documentation page where we have a number of our targets listed. The TDA4VM is listed under CPU targets, and here's the documentation page for it. This target's sitting on my desk. I have gone through and done a number of the installation steps, which take a little bit of time. but the main key here is that the TDA4VM is a network connected device and for which you can SSH into it. And in order to get started with Edge Impulse, you do need to install the Edge Impulse CLI tool, which will eventually give you this command called Edge Impulse Linux, which is what I'll run here today. So I've already done the installation on the target. I'm going to SSH into it. And then I will be able to run the Edge Impulse Linux command line tool. Before that though, I do need to set up an API key. So I'm going to get an API key here for this particular project. We'll create a new one, call it Josh. And it's a development key so we can copy it. I'll grab this API key and then we'll use the command line tool to connect to it. Edge Impulse Linux. And then API key. Go from there. What this is now doing is connecting the board to this particular project so that we can connect webcam images and we can start building an image data set for which we're going to do a face detection demo. I'll call my board Josh. And here it says, hey, go over to edgeimpulse.com studio project 519, which is where we're already at. So we can go back here to the project and go over to devices and ensure that our device is connected. So here we have our device connected. And now we can go to data acquisition and start building up a data set. So I'm going to connect my camera and take a live image from the USB webcam that is connected to the TDA4VM on my desk. And we'll start taking pictures. So 1, 2, 3, we'll just do a few like that. And as you can see, Edge Impulse has now collected the data. We have a number of different samples presented here. And we can go in and then label it. Since we're going to be doing object detection or face detection in this case, I am going to put a bounding box around my face. We'll call it face. And we'll set this label. So I'm going to save this label. And now you can start seeing the auto labeling feature of Edge Impulse. So that the next image has automatically come up and has already have a bounding box around that, around my face. So we can do this with a number of different data sets. Time series data has the ability to take a long sample and then segment it out so that you get each individual data set as well. Or different images with different labels can help automatically go through the queue and try to figure out what label needs to be applied as well. Once you have your training data set up, it's important to take some test data with your model. Again, we can connect test data as well. So we're just going to take a few shots as well. And we have a labeling queue that we can set up. Again, we'll call this face. Save the 3 labels. Great. Ideally for many models, you have to have hundreds of images, and depending on some applications, you may need thousands to do a proper training data set. Edge Impulse does have upload limits on the free account. So if you have a free developer account, you can train up to 20 minutes and have 4 gigabytes of data. And then we have paid versions of Edge Impulse that allows you for more training time and more data storage. For here, we're just collecting a few images. I have a project that already has many images that have both been collected by the device, or we've also uploaded images from a wider face training set as well. So here you can upload stock images or even take images from your cell phone and get them into this data set. So once you collected images, it's time to design your impulse. Okay, an impulse is a series of steps in order to feed the model the correct data inputs and then get that correct inferencing result out of it. Since we have image data already in our data acquisition tab, Edge Impulse already knows that you have image data and that gives you this default box to work with. And so what it will do here is it's saying that out of your data set, before it feeds it into a model, we're going to shrink the model down to a 96 by 96 image. And that resize mode can have a number of different options. Once that device has been shrinked, we will process that image and we will set that up in the next step. And that would either means that we're going to keep it as an RGB image or convert it to grayscale. And then lastly, we'll select a learning block. In this case, since we decided earlier on that we're going to do object detection, we'll select this here. And we haven't been asked to describe which model we want to train yet. Again, this is a high-level overview about what are the steps necessary to generate the inferencing or the output features for the model. So that is what an impulse is. So we'll save this. And then on the left-hand side here, we have a few new tabs. From here, we are taking the raw data of like the faces that I have, and we can kind of organize and select which face or label that we want to look at. And what it's asking us to select is, do we want to keep it as an RGB image or a grayscale image? We'll keep it as RGB for now, and we'll generate these features. And at this point, we're going through over the data set, and since it's only just a few images, to make sure that these data that we have in there has been pre-processed and ready to be fed into the training pipeline. So this runs relatively quick. Oh, we only have 3, we need to do 2. Let's see here. Reducing dimensions, okay. Job completed. All right. Since in this data space, we don't have a lot of images, but if we go to one where we collected hundreds of images, we can go over here and look at the feature set and see how things have been organized. What this view is trying to present is, let's say we had multiple labels, let's say our face, hand, appendage, limb, foot. What it's trying to show here is how much separation there is per image. And this is good to tell that you might have potential problems in your deep learning training if there's going to be problems with classifying something. Maybe there's a lot of data sets that don't have a lot of separation, or you may even mismanage or misclassified something. So here you can kind of get a preview about what is contained in your data set before you even begin model training. To do model training, we come back over here to our object detection as part of our impulse design. From here, you can select a number of different models. We have mobile nets. FOMO is our faster object, more objects, a model that Edge Impulse is developing, which is based upon MobileNet. And then we're adding in different models from Texas Instruments that'll be available soon, such as Yellow X, Yellow V5, that will run optimized on the TDA4VM. For now, we're going to go ahead and select FOMO, and we can kick off a training cycle. This training is going to go relatively quick because we have a very short set of data. On a project like this one that has about 300, 400 images, to do a number of training cycles in the cloud takes about 20 minutes to do just this one. But this little example set is going to go relatively quick because it has just a very small sample set. Of course, this is not going to train well. You have to have much, much more data to train against it. So let me hop over to this project now in full, and then we'll go do model testing and then deployment. Once you've done and trained your object detection model, you get a score and a confusion matrix that kind of tells you, at least gives you some metrics to go against to see if your training is done good or not, right? This F1 score happens to be for object detection. We have MAP scores for other data sets that are for bounding boxes. And then for anomaly detection scores, we have different metrics for those as well. In this case too, we'll also try to give a hint of on-device performance. Here we've selected to train against the TDA4VM target. This is a drop-down box from which we have many different products as well. And then we will give you a hint about saying, okay, what's the peak RAM usage and flash usage for this particular target? We'll now go over to model testing, and I will go back to my CLI tool, and I'm going to connect to a different project. This one is this project, so I'll go grab this API key that I've set up before. And we'll connect the device to this project. Great. So we'll go over here to devices. Device has been connected before. So now we'll go to model testing. So in this project, we've already had done training because it takes a long time. So it's not to train during a webinar, but we want to go ahead and test it. So we'll come over here to model testing, or sorry, live classification. And what this does is we come over to and select our device. And interesting enough, the device is not showing up. Let's go over to devices and see if it is connected. Let's delete it and bring it back in. Make sure I got the right API key. There we go. All right, it is back in. We'll go to live classification. Yeah, the device is now connected again. So here we have the device, and we already have the model tested and trained. Already trained into the in edgeimpulse.com. So now we're going to sample and see how the model would actually classify it if it was actually running on the device. So here we haven't even deployed back to the device. Again, we're just using the camera that's integrated with the system to do model testing. I forgot to mention earlier that this API that we're using is open source, right? It's in GitHub. And so you can also integrate this for a non-development board. So let's say that you have a product that you're developing for a real life application. If it's network connected, or even if it has a serial connection, you can still do this kind of data collection with that device. So let's say you use a different camera, IR camera, low resolution camera, something of that nature. You can collect and classify data with that camera with edgeimpulse.com. So it doesn't have to be the ones that we support out of the box. As you can see here, I just happened to do one sample. We'll do another one where I'm a little farther back because FOMO tends to do well with people that are a little further away from the camera. And yeah, it's detecting my face. It should have this kind of performance on the device. So it's right there centered up in my face. So now we're actually going to go to a deployment. From deployment, we have a number of different options. You can export as a C++ library, which gets you a compiled down model. And then if you're familiar with the edgeimpulse SDK, there's an inferencing SDK from which works across all our devices. And this will be true also with the TDA4VM. What's required to use the TDA4VM and also in order to use hardware acceleration is an exportation to the TIDL libraries. When you click here and click on build, this will generate model artifacts that can be used in your application so that you can get the full hardware acceleration that you need. So if you're wanting to use our edgeimpulse SDK with full hardware acceleration, this is the deployment that you would need to do. Manisha had earlier said that there's these set of APIs and tools, GStreamer, TIDL, in order to use a device. This is actually what edgeimpulse has used to develop these applications. So we're using the TI compilation tools, the TI abilities to work with GStreamer to do webcam imaging and to build these models so that they can run accelerated on the target. Here on this build, right, I generated the model artifacts and we can open them up and see what's inside. Go over here to this folder. The folder here, we have the edgeimpulse SDK, which has been ported to the TDA4VM and built for that target. And then we have the model artifacts that are needed in order to run and build against, to run accelerated on the TDA4VM. So if you already have an existing application and you're trying to use edgeimpulse for model development, you can use this build system just to generate these artifacts and then go import into your application. Going back as well, there's the ability to also do a no-code deployment option. I'm going to show it to you from a different way. You can click on this button here and do build, and it will give you a file from which you could then transfer over to the device. Alternatively, since you already have the SDK, the CLI tool running on the TDA4VM, we can initiate a build and deployment direct from the command line. So the command for that one is edgeimpulse Linux runner, and we give it the API key of the project, and we click off from there. And what this will do is instead of giving you a zip file of a library, and I've already done this before, it will initiate a build on the system and then download that model onto the device without having to invoke extra steps of you having to do manual copies and things like that. So I have this model already been built. And so it's already on the device from a previous run right before the webinar. And what this is showing here is the bounding box of where my face is in the image. So this is an output. This is a struct output that we're showing on the command line from the Edge Impulse SDK. But we do have a preview that's available as well. So when you start the command, it'll say that there's a web page that you can navigate to. So you can get a sense about how the device is performing. So there I am with face detection. And this happens to be a 224 by 224 image as well. So to wrap it all up, what we walked through today was how you can collect data with the device, how you can design a model. We started off with a very simple, just a few sets of image captures and then trained for a FOMO model. And then we switched over to a project that had already done the training, which took many minutes to conduct for a lot of images. Then we tested that model without having to deploy back to the device, walked through just a few features of that. And then we did two types of deployment, right? We did the deployment for the C++ application, which gives you the model libraries from which you can then go build and integrate into a project to your own code base. And then we also did the no-code Linux deployment option, which is what I demonstrated here at the end. Edge Impulse also has a lot more to it to just collect, design, test, and deploy. There's features such as Eon Tuner and Eon Compiler that we did not cover today, as well as other tools to ensure that you can build a whole ML ops platform so that you can continuously generate models, develop them, deploy them, and refine them so that you can get your model out there faster in a more efficient way in the field. So Manisha, if you want to talk about our calls to action today, and then we can do our Q&A session.
Yes, yeah. So thank you, Joshua, for that wonderful live demonstration. People, if you got excited, and this is a very powerful processor. Actually, Joshua just showed the first AI model that they have integrated in the service with the smaller resolution, images, but quite powerful processor. You can run multiple AI models simultaneously, including YOLO-X and the human pose estimation based on YOLO-X or point pillars and others, right? And pre-optimized from our model zoo. So if you have any of your use cases, please do go check out our SK-TDA4VM Star Kit. And while you are waiting for the Star Kit to be delivered, you can get started today by logging on to our cloud service, which is totally free. Just go to ti.com/edgeaicloud and just get started with the Edge Impulse with TDA4VM using the link that is being shown on our slide. And I also wanted to talk about if you have a cool use case, we are giving some free starter kits for you. And what I would like to do is to actually share my screen for you to see where you can share your use case with us later. And we will screen them up, and then the top 5 winners will get a free starter kit. Let me share the screen for you to have the information. All right. So please share your project ideas either to our one-off mailing list, which is tda4vm@list.ti.com, or tweet me at my handle with the hashtag TDA4VM project. And we look forward to your project ideas. And after, our panelists will screen them up, and top 5 will get one free starter kit. So over to you, Joshua, again, if you have more things to talk about. Otherwise, we can take question and answer at this point. Oh, I cannot hear you, Joshua.
Oh, sorry about that. Yeah, no, I think Q&A would be good. And Louisa, I think we had some questions come in on the chat.
Did, yeah. So the first one, is there still work in progress on the integration with the Edge Impulse and TI platform?
Absolutely, yes. So today we're kind of doing basic model support for TF Lite and for the acceleration of that runtime. We are bringing in Onyx support very shortly. We can already train the YOLO-X models from TI, and then we'll be able to deploy those as well after this webinar, when those come live, we'll be sending everybody an email about that who's been on this webinar. And then we have a number of models that are coming soon. If you go over to the documentation page for the TDA4VM, you can see some of the other models that will bring in natively to Edge Impulse. To add to that, there is the bring your own model support for Edge Impulse, which is to say that if you have a model that you've already developed, you can extend Edge Impulse through a Docker container so that you can actually train and deploy that model against many of our products that we support officially. So again, edgeimpulse.com, the keyword that you want to search for is bring your own model, or go to the TDA4 documentation page and see what we're adding support for soon.
Great, thank you. And in addition to that, how many MCUs 32-bit are supported by Edge Impulse?
A number of 32-bit MCUs have been supported on Edge Impulse. Again, on the officially supported page, we have a list out there. A lot of Cortex M4 devices, but the TDA4VM by far is the most powerful one that we have currently on the officially supported platform list.
Great, thank you. Okay, what kind of use cases do you see TDA4VM in?
Manisha?
What kind of use cases do you see in TDA4VM, right? So really, starting from, as I mentioned, automating the factory process, so factory automation to building automation to retail automation to smart cities, right? So starting from the machine vision cameras for single camera to the multiple sensors connected to it, or smart cities traffic monitoring cameras, right? Bring single camera to multiple cameras over there. AI box and gateways where we can process the inputs on the 8 channels simultaneously, where you receive the input over Ethernet, and we have Ethernet port, 8 Ethernet ports in Ethernet switch integrated into that. So you bring the 8 cameras input, do the decoding, AI processing, and re-encoding, and make your all dumb cameras around smarter, right? Very good use case, and customers are on production already with such use cases. To the robots, right? Whether in your warehouse or last mile delivery, with bringing in multiple cameras, vision, radar, sensor fusion, AI, controller. There are really, really variety of use cases from low end to the high end that are being solved with TDA4VM, and extend it to the industrial mobile machineries such as the tractors or the forklifts or the construction machines, mining machines, the cameras around that, multiple of them under ruggedized environment, under extreme weather, temperature. So these devices or these processes of our are industrial grade and auto grade qualified. So really good for wide spectrum of AI applications.
Okay, thank you very much. Where is this chip available and how much is it?
Yes, absolutely. You can buy our SoC from ti.com, and I'll just put the link on the chat window later. And the cost ranges from it depends on the volume of your product, right? But the 1KU pricing would be somewhere around $50+ range, so somewhere around $50 to $60 range, and you can check that on ti.com.
Great, thank you. And then I've got 2 questions that are pretty much the same. So do you have examples of instant image segmentation?
Absolutely, right. We have multiple models in our model zoo, which are pre-optimized for our processor. And I can name few of them, which is the FPN and the Deep Lab V3, and then the UNet. So these are a couple of examples that you can check out from our model zoo pre-optimized with different backbones, and you can bring your own model as well. And if you have certain needs, I would love to hear what your use cases are, what you're trying to solve, and why a specific model is so important to you compared to the others that we are supporting in our model zoo.
And Edge Impulse, and for segmentation, we don't have that at the moment, but that's something that you definitely can bring into bring your own model for testing and training, and then eventual deployment as well. So the capabilities of the TDA4VM and the TM Model Zoo, we should definitely add more support to that as we go. And so we'd love to learn more about the use case and application if you want to reach out to us.
Great, thank you. And then one final question. What account types do you have for people using the Edge Impulse platform?
Yeah, so in general, we have two accounts. There's a free tier, just sign up with an email address and you get access to 20 minutes and 4 gigabytes of data, 20 minutes of training time, 4 gigabytes of data. If you intend to do probably more serious application development for real deployment, you probably need more than that space and that training time. So there's a tier enterprise account. It also has a number of extra benefits in just the training and storage space, right? There's a whole API that you can use against it. Ways of collaborating and features, and then expanded bring your own model and DSP support as well.
Perfect, thank you very much. That's it for the questions, I believe. So yeah, I'd just like to say thank you very much. We'll be following up on the webinar with the slides afterwards. So you should see those in the coming days. But if you have any other questions in the meantime, please contact us via social media or through our forums.
Thanks, everyone.
Thank you.
Thanks very much. Bye-bye.
Bye.